Good morning, students. How you doing? Good. Okay, we're starting a brand new unit today, as you notice. We haven't done this before, have we? No, we're working on landforms before, and this is completely different. So what we're going to be working, I call this the force experiment, okay? Okay, because we're going to be doing a lot of stuff with force today. And as you see, my farmer here is trying to do something with his donkey. What force is he using right now? Pull, right. He's going to be pulling. So that's one of our forces, isn't it? Okay, so let me get this working. Who over here wants to be my person? Would you like to run this for me today? Okay, thank you. So she's going to run this for us today. So our teak for this morning, okay, is that we are going to be working on 5.6D. 5 means it's what level? Fifth grade, right, and it's a 6.1D, and it's called experimenting with forces. This is one of the things you need to know, okay? Can somebody read me the teak, please? Yes, ma'am, go right ahead.
The student is accepted to design an experiment that tests the
Effect. Yeah.
of force on an object.
Very good, very good. Can somebody tell me what this means in their own words? What are we going to try to do? What do you think we're going to try to do? Yes, ma'am. Okay, what do you think?
We're going to design a project to show how force works on other objects.
Okay, there we go. That sounds good too. Anything else anybody wants to give? Yes, ma'am.
The way that an object like forces when you make it, when you pull it or push it, it moves at your force.
Okay, so we're going to see about that, aren't we? Yes, sir.
We're going to do an experiment that shows how the force acts on the object.
On an object, that's even better. So we're looking at how something's interacting, isn't it? When I walk on the floor, am I using force to walk? Yes. Am I interacting? What am I interacting with? The floor, right. So it's my foot. Is my foot pushing or pulling? Pushing. So I'm using the pushing force right now, aren't I? You don't even think about this sometimes, do you? No. Okay, so let's see what our objective is. Can you go ahead and hit the next one for me, ma'am? Awesome. So our unit, this is the whole unit. It's going to be about 2 weeks, guys, okay? So by the end of our unit, we're going to do students will design an experiment that tests the effect of force on an object with 80% accuracy according to a rubric. How many of you want to design an experiment? Oh, wow. So it's going to be a fun unit, isn't it? Yeah, okay. Next one. Let's look at what we're going to do today. Today, we're just starting, okay? We're just going to get going, that little engage thing Miss Finney likes to do, right? So you're going to design a domino chain reaction. Do you see your dominoes you got there? Yeah, I gave you a bunch, didn't I? Okay, showing the effect of a simple push and the transfer of energy. Now, we know what a push is. You've all said that, right? What do I mean by transfer of energy? What do you think I mean? Yes, sir.
Your force is moving to the other object.
Right, moving to another object. Very good, very good. Yes, Traylon.
Because when you push the domino, your energy transfers to that domino when it knocks
Right,
the other domino.
because of does the energy disappear? No, it just keeps moving, doesn't it? Okay, so let's go ahead to the next one. Super. We're going to watch a short video, and this is to show you, these are real elaborate, okay, chain reactions on dominoes. These people do contests every year, and this is off of a contest. Runs about 3-4 minutes here. There are 2 words I want you to think of. Let's see if you know them. There are 2 types of energy we saw in that chain reaction, okay? The letters are a hint. Does anybody have a clue? And by the way, the frogs are a hint too. Do you know what the first one is? What's the frog doing? Hopping. What is it? No, he's hopping. What's this type of energy called? It starts with a K. When you're moving, does anybody know what movement of energy is called? New word for you. Just wanted to see if you had it. No one? You ready for your new word? When I say it, you say it. Ready? Kinetic.
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 Kinetic. So we're going to look at kinetic energy is the energy of the object that is moving. So when it's in motion, he's doing kinetic energy right now. Do you see that? Because he's moving, this is kinetic energy, okay? Now, when they're not moving, my other frog's not moving, is it? So this word, ready? Potential.
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 So that frog has potential energy because he could move, couldn't he? Yes. So what's the energy of movement called?
Kinetic.
What's the energy of movement when you don't move?
Potential.
Let's try it again. Energy of movement is?
Kinetic.
Energy of not moving?
Potential.
Means you can. Okay, so today we're looking at potential because all of your dominoes are going to be standing there, aren't they? And what's going to happen when you bump one? What type of energy? Kinetic energy, right. So there's your 6th grade words for the day, okay? So here's your mission. Are you ready? Yes. Okay, if you look at the bottom of your box, there is a paper. So go ahead and start taking your stuff out, okay? Awesome. So there's your mission paper. Okay, so here's what... I'm so sorry, Jupiter. I forgot you. I don't normally forget the largest planet. My fault. There you go. Okay. Okay, here we go. So your mission with your boxes of dominoes, you're going to build a chain reaction display. I'm going to give points, okay, for each domino used and 10 points for each split reaction. Remember how they had 2 dominoes and one hitting it? That's a split reaction, okay? And then 15 points for creativity. So right now what I'm going to give you is I'm going to give you 5 minutes to plan. Do you see how you have a box on your paper? So you're using your pencil. Okay? And then what you will be doing, ladies, one moment, and then you'll go. One moment. Thank you. Awesome. You will be doing this on the floor. Okay? Okay, 5 minutes.